Hey guys, in today's lesson we're going to talk about the fundamental theorem of algebra, which is found in section 2.5, part 1. Our objectives are to use the fundamental theorem of algebra to determine the number of zeros of polynomial functions and to find all zeros of polynomial functions including complex zeros. Alright, just a little vocabulary. The fundamental theorem of algebra was first proven by the German mathematician Carl Friedrich Gauss. The theorem states that if f of x is a polynomial of degree n, where n is greater than 0, f has at least one zero in the complex number system. Okay, so in example 1, we are asked how many zeros does a function f of x equals x minus 2 have? What are they? And then to verify using a graphing calculator. All right, so we answer that based off of the power of our leading term. So the power of the leading term is 1. So there is 1 0. And it says, what are they? So we would, essentially, if we did this by hand, it would be setting that factor equal to 0, right? So x minus 2 equals 0, add 2. So we get x equals 2. And we can also verify that on a graphing calculator. So if we type that in, it'd be some linear function that went through negative 2 and the slope is up 1 over 1. So the line would look, I missed it just a tad, but that 0 is right there, okay? So that's what it would look like. So we're done with example 1. In try 1, it says how many zeros does a function f of x equals x squared minus 6x plus 9 have? What are they? And verify using a graphing calculator. So again, we just focus on the highest power, which is squared. So there are 2 zeros, okay? And to find them, the best thing that we can do is to use the AC method since this is quadratic. So AC would give us positive 9. So the factors of 9 are 1 and 9 and 3 and 3. The ones that work to give us negative 6x are negative 3 and negative 3. So it gives us x squared minus 6, excuse me, not 6, but minus 3x plus 9. And again, this is all set equal to 0. Group and group. I can take an x out of the first one and be left with x minus 3. On the second one, I can take out a negative 3 and be left with x minus 3. So our two factors are going to be x minus 3 and x minus 3. So our zeros are x equals 3 and x equals 3. Now, technically, there are 2 zeros. They're non-unique, which means that they have a multiplicity of 2. If we remember with graphing, it means at 2 it's going to bounce. But all in all, there are 2 zeros that are listed. Okay, let's keep going. In example 2, it says how many zeros does the function f of x equals x cubed plus 4x have? What are they? And to verify using a graphing calculator. So again, on this one, we focus on the highest power, which is 3. So there are 3 zeros. Okay, what are they? Well, we can factor to figure them out. So if we have x cubed plus 4x and we set it equal to 0, the greatest common factor is x, and we're left with x squared plus 4. Now, the first one is pretty obvious. We would have x equal to 0. But the second one, x squared plus 4, if we set x squared plus 4 equal to 0, we would subtract 4. And we'd have x squared equal to negative 4. Then if we take the square root, we would have x equal to plus or minus. The square root of 4 is 2, and because it's negative, it'd be plus or minus 2i. So we have 3 zeros, and they are x equals 0, positive 2i, and negative 2i. So now we're starting to get into our complex zeros, but there are 3 of them listed. With try 2, again, how many zeros does the function f of x equals x to the 4th minus 1 have? What are they? So here, we're going to actually have to use the substitution method. So first of all, there are 4 zeros. And let's figure out what they are. So x to the 4th minus 1 equals 0. Again, like I said, to be able to kind of factor this by hand, since there is no greatest common factor, we're going to have to use the substitution method. So I'm going to replace a as x squared. So this is really x squared minus 1. okay? So that's like a squared minus 1. Now what that should look like is difference of squares. All right, so that should be a plus 1 and a minus 1 equal to 0. And that's as far as we can go with a. So we're going to go back and replace it again. So that gives us x squared plus 1 and x squared minus 1. Okay? In the end, this x squared plus 1, if we set it equal to 0, we would get x squared equal to negative 1. Take the square root. So x equals plus or minus I. So we have 2 zeros right there. And then if we take this one, we have x squared minus 1 equal to 0. Again, that's technically difference of squares. So I could either solve it for x, or I can factor it some more to get x plus 1 and x minus 1. But I'm just going to solve just this time because I'm out of space. So I get x squared equal to 1. Again, take the square root. And I get x equals to plus or minus 1. This is really much more particular about why we always get that plus or minus. Remember, if you have an even root, you will get two answers. So the 4 zeros are x equals I, negative I, 1, and negative 1. So we have 4 zeros. And again, we could double check them on a graphing calculator. The only ones that will show up on a graphing calculator, however, are the real numbers. But again, that's something, okay? So let's look at our next problem. In example 3, it says, write f of x equals x to the 5th plus x cubed plus 2x squared minus 12x plus 8 as a product of linear factors and list all of its zeros. So the first thing we're going to start with is trying to find those possibilities again, right? So to find the possibilities, I'm going to just put pos for possibilities. Remember, it is the factors of your constant over the factors of your leading term's coefficient. So that'd be the factors of 8 over the factors of 1, which means really all we're going to have are whole numbers. So we will have plus or minus 1, 2, 4, or 8. Okay, I like to start with the positive factors. So if I had, for example, positive 1 as a factor, it would look like x minus 1. But anyways, we're going to test positive 1 and see if it works. Now remember, we need to rewrite our polynomial with just the coefficients. Again, if you have any gaps, you need to substitute it with a 0. So that's 1, 0, 1, 2, negative 12, and 8. Again, all I did was write my coefficients and my constant. So if I drop down the 1 and I start the process, 1 times 1 is 1, 0 plus 1 is 1. 1 times 1 is 1, 1 plus 1 is 2, 1 times 2 is 2, 2 plus 2 is 4, 1 times 4 is 4, negative 12 plus 4 is negative 8, 1 times negative 8 is negative 8, negative 8 plus, 8 plus a negative 8 is 0. So with this, this essentially says that x minus 1 is a factor. So that's my first factor. Now, remember, I really should have 5 zeros, so I've only found my first one, okay? Now, because we have so many more to find, we should double check to see if 1 could be an additional 0, because, again, there are some times that we have repeated zeros, okay? So I could, again, substitute in 1. And so I'm just going to use the same coefficients that came from below. So in other words, what I'm saying is I'm going to use these numbers here. So it becomes 1, 1, 2, 4, and negative 8. That would give us 1, 2, 2, 4, 4, 8, 8, and 0. That's not negative 0, just 0. So we actually have another factor at x minus 1. So we have 2 x minus 1s. All right. Now, to be honest, really what I can do is I don't necessarily have to just keep trying to guess what these factors are. Really, I can kind of guesstimate by using our graphing calculator. So if we type this function in as our y1 in our graphing calculator, we'll see where it's crossing the x-axis or even touching the x-axis. And so what we notice is on the graphing calculator, it bounces at 1, but we also see another 0 at play, and that 0 is negative 2. So if I keep going with this process, I'm going to test negative 2 using these numbers that we just had. So we have 1, 2, 4, and 8. Because, by the way, we were at 5th power. Here, this was 4th power. Here, this was 3rd power. So now, whatever answer we get from here will be in 2nd power. So here we go. Negative 2 times 1 is negative 2, 0. Negative 2 times 0 is 0, 4. Negative 2 times 4 is negative 8, 0. So this actually means x squared, there's nothing for x, but there's a plus 4. To find our last two zeros, we just simply need to set these equal to 0. And so, by the way, that minus 2 is really an x plus 2 factor. So if we set it equal to 0, we would subtract 4. And we have x squared equal to negative 4. If we take the square root, x will equal plus or minus 2i. Okay? So in the end, our factors are f of x equals x minus 1 times x minus 1, because we had two of them. Or you could say x minus 1 squared, it doesn't matter. Then x plus 2, and then we can't forget our last two factors that were complex numbers. So we'd have x plus 2i and x minus 2i. Honestly, we could have gotten all of these zeros from a graphing calculator, but the only ones that we would not have been able to spot are the complex numbers, okay? So we are done. Let's take a look at our last problem. It says, write f of x equals x to the 4th minus 16 as a product of linear factors. So on this one, I'm just going to do this one by hand. We can use a graphing calculator to help us start it, but to be honest, it's probably just easier if we do it by hand. So x to the 4th minus 16 equal to 0. Again, this is another substitution problem, so we're going to substitute a as x squared. So this is x squared squared. That's how we get to the 4th power. So x squared squared minus 16 equal to 0. So that's really a squared minus 16 equal to 0. If we factor that as difference of squares, we'll have a plus 4 and a minus 4 equal to 0. That's as far as we can go with a. So we're going to sub our x squareds back in. So it's x squared plus 4 and x squared minus 4 equal to 0. And again, that came from here. So this x squared plus 4, if we set that equal to 0, we would subtract 4. And we have x squared equal to negative 4. Again, take the square root. And we get x equals plus or minus 2i. Okay? And then from there, we have this x squared minus 4 equal to 0. If we add 4, you get x squared equal to 4. Take the square root. And again, I could have done difference of squares, but it's the same thing. This will equal plus or minus 2. So we have to take these zeros and write them as factors. So that would be, as a final answer, f of x equal to x plus 2i, x minus 2i, x plus 2, and x minus 2. And that makes sense because this told us that we were going to have 4 zeros or 4 factors, and that's exactly what we have. All right, guys, if there are any questions, please be sure to come see me for tutoring.